Already, we have discussed the vapor compression refrigeration system in our previous chapter. That vapor compression refrigeration system is used for refrigerator, air conditioner, etc. So vapor compression and compression means there is a compressor. The compressor is used to compress the refrigerant. Now, in this chapter, we'll study vapor absorption refrigeration system. Vapor absorption, so you see the word compression is missing here. Compressor is missing. That means in this system, there is no compressor. No compressor. So we replace the compressor by some other device. So this is the basic difference of vapor absorption refrigeration system. Objective. Here we will introduce vapor absorption refrigeration system, and then we'll explain the basic principle of vapor absorption refrigeration system. We'll compare vapor compression refrigeration system with vapor absorption refrigeration system. This is what is the difference between, basic difference between these two systems. Then we'll obtain maximum coefficient of performance of ideal absorption refrigeration system. Already we have deduced coefficient of performance for vapor compression system. Now here we'll find the expression for ideal absorption system. Then we discuss properties of ideal and real refrigerant absorbent mixer. Here you see this is a refrigerant and absorbent mixer. We'll study which one. In case of vapor compression, we are using R11, R12, R22, R134A. These are the refrigerant generally we are using in vapor compression refrigeration system. But in case of vapor absorption system, instead of using this one, we later on will explain, we'll use water plus lithium bromide solution. We'll use water plus ammonia solution. So these are the refrigerant and absorbent mixer. This is the mixer. In this system, water will act as a refrigerant, and in this system, ammonia will act as a refrigerant. So we'll discuss in details later on. Describe a single-stage vapor absorption refrigeration system with solution heat exchanger. Discuss the desirable properties of refrigerant absorbent pairs for vapor absorption refrigeration system. That means pair means this is the pair, water and lithium bromide, this is the pair, and water and ammonia, this is the pair. So these are our objective learning outcome. After completion of this chapter, you can able to list salient feature of vapor absorption refrigeration system, and compare them with vapor compression refrigeration system. You'll be able to explain the basic principle of absorption refrigeration system, and you will describe intermediate and continuous vapor absorption refrigeration system. Then third is that find the maximum possible coefficient of performance of vapor absorption system. Then you'll be able to explain the difference between ideal and real mixer using pressure composition and enthalpy composition diagram. Then you'll be able to draw the schematic of a complex single-stage vapor absorption refrigeration system. Then we'll be able to list the desirable properties of the working fluid. So these are the learning outcome of this chapter. What is vapor absorption system? Let's see. In case of vapor compression refrigeration system, what is the input? The refrigerant is compressed in compressor. In compressor, it is compressed. refrigerant is compressed. Where the compressor will get the energy? This is the electrical energy input. Electrical energy is the input to the compressor. Compressor run, compress, and it compress. But in case of vapor absorption system, there is a no compressor. In vapor absorption system, there is a no compressor. So there is a no need of using any electric energy to compress the compressor. Instead of using this electric energy, we will use heat energy. You see, you will use heat energy in vapor absorption refrigeration system. The required input to absorption system is in the form of heat. Always remember, not in the form of electrical energy. Hence, these systems are also called heat operated or thermal energy driven system. Since conventional absorption system use liquid for absorption of refrigerant, later on we will discuss, these are also sometimes called wet absorption system. Why it is called heat operated? Because heat energy is used in the refrigerator. Heat energy is used. So it is called heat operated or thermal energy driven system. Then it is also used, conventional absorption system use liquid. So it is also called wet absorption system. So this is the basic definition of a vapor absorption refrigeration system. Now, basic principle. Now here you see lithium bromide. Lithium bromide, it is a salt. Lithium bromide is a salt. And then next is the water. So in general, at atmospheric pressure, the water boils at 100 degrees centigrade. This is the boiling point of water. Now, if we mix the lithium bromide salt to water, so this is so water is the solvent. It is the solvent. And this is the lithium bromide is a solute. So if we add lithium bromide to water, then it becomes lithium bromide water solution. This is now solution. The normal boiling point of water at atmospheric pressure is 100 degrees centigrade. If we prepare a solution of lithium bromide, then the normal boiling point of this solution increases. That is, instead of 100 degrees centigrade, it will boil. Suppose at 120 degrees centigrade, it will boil. That means normal boiling point of the solution now increases. So this is the basic concept of vapor absorption refrigeration system. So you see, when a solute such as lithium bromide salt is dissolved in a solvent is water. The boiling point of the solvent, that is what boiling point of the solvent is elevated. Now you see boiling point of this is elevated. On the other hand, if the temperature of the solution, solvent plus solute is held constant, then the effect of dissolving the solute is to reduce the vapor pressure of the solvent below that of the saturation pressure of the pure solvent at that temperature. Now try to understand this paragraph. So this is the basic principle where all the vapor absorption system works. So this is the basic principle. Now we see what is written in this paragraph in the first point 1. So water at atmospheric pressure 1 bar, 1 atmospheric pressure boils at 100 degrees centigrade. Okay, so this is the first condition. Number 1, water at suppose at lower temperature, if you go to a hilly area where it is a pressure is less than 1 atmospheric pressure. Then boiling point of water will be less than 100 degrees centigrade. Okay. So at a high altitude, the water boils at maybe it boils at 30 degrees centigrade at sufficient high altitude, where the pressure is far below than the atmosphere. So boiling point reduces. So this is the first concept. The second point is that if water mixed with lithium bromide, then the eh, the normal boiling point of the solution increases, will be boiling point will be more than 100 degrees centigrade. Now, you see, if we want to fix the boiling point of this solution 100 degrees centigrade, then what we will have to do? We have to reduce the pressure from this concept. If you're reducing the pressure, then boiling point decreases. Now you see, water, if we mix with lithium bromide, it will, at 1 atmospheric pressure, the boiling point is elevated. That is, at more than 100 degrees centigrade, it will boil. But our main aim is to, if we want to make the 100 degrees centigrade boiling point constant, then the other alternative is we have to decrease the atmospheric pressure, So we have to decrease the pressure. So this is the concept. On the other hand, if the temperature of the solution is held constant, okay, then the effect of dissolving the solid is reduce the vapor pressure. That means the pressure is reduced. Next one. If the solute itself has some vapor pressure, so this is the second point. There is a volatile solute. Now suppose one is solvent is water, now solute is lithium bromide. So if the solute has some vapor pressure, it is a volatile solute, that is, it is vaporized. Then the total pressure exerted over the solution is the sum of total partial pressure of the solute and solvent. So in this case, total pressure P total exerted by the solution will be the partial pressure of solute plus partial pressure of solvent. So this is the total pressure exerted. But if the solid is non-volatile, you see, if the solid is volatile, then this is the total pressure. But if the solid is not non-volatile, when it will be non-volatile? When its boiling point is much greater. Suppose for lithium bromide, the boiling point is more than 300 degrees centigrade. So water will boil, but it will not boil. So you will not provide any vapor pressure to the system. So if the solute is a non-volatile, or if the boiling point difference between the solution and solvent is large, more than 300 degrees centigrade, then the total pressure exerted over the solution will be almost equal to the vapor pressure of the solvent only. So in this case, the total pressure will be vapor pressure or partial pressure of solvent. Because you see, the solute, it will not vaporize, so there will be no pressure exerted. So this is the basic concept of vapor absorption refrigeration system. In the simplest absorption refrigeration system, refrigeration is obtained by connecting two vessels, with one vessel containing pure solvent and the other containing a solution. Now you see, this principle can be used to obtain refrigerating effect. How? The basic principle is there. So there are two vessels, one vessel, one vessel. So first we'll read the sentence. With one vessel containing pure solvent and the other containing a solution. Since the pressure is almost equal in both the vessel at equilibrium, the temperature of the solution will be higher than that of the pure solvent. Why? This means that if the solution is at ambient temperature, then the pure solvent will be at a temperature lower than the ambient. Hence, refrigerating effect is produced. Now you see, this is the statement. Now we'll explain. So this is, you see, this is the initial condition. So there are two vessel. This is number one vessel. So this is number two vessel. Now we see what is the sentence. So we are connecting these two vessels with one vessel containing solvent and the other containing a solution. Now you see, in this vessel, so these are two vessels. One is solvent, water, and here you see, this is a solution. 50% lithium bromide, and this is a solution. 50% here, 50% lithium bromide, and 50% water. Okay. Now we see, in this case, the temperature is maintained constant 30 degrees centigrade. Temperature is constant, suppose 30 degrees centigrade, which is the atmospheric temperature. So at 30 degrees centigrade, so this is the atmospheric pressure. This is the atmospheric pressure, 4.24 kilopascal. So it is maintained here. Now, because we are adding lithium bromide, then what happened? If we add the lithium bromide, and if the pressure is at 4.24, then this temperature definitely increases. Why? From this basic concept. From this concept, you see. From this concept. When a solute such as lithium bromide salt is dissolved in a solvent, the boiling point of is elevated. That means here this is elevated. So to maintain this one at 30 degrees centigrade, what we have to do? We have to reduce. That means this pressure is reduced. Now you see this pressure is smaller than this one. This one. So this is the concept. Now the valve is closed. So we are maintaining this at 4.24 kilopascal, and this is maintained at 1.22 kilopascal. If we maintain it this pressure, then the solution temperature will be the 30 degrees centigrade. And if we maintain this one and this pressure, the solution temperature is 30 degrees, the solvent water temperature is 30 degrees centigrade. Now valve is closed. The next part. Now we'll open the valve. The valve is open. Valve is open means what happened? Now this is connected. As a result, what happened? As a result, originally the pressure is 1.22 kilopascal. This is the original pressure. So if we open this one, now the whole pressure will be 1.22 kilopascal. So this is the whole pressure. You see, this is 1.22. We open it now, so this pressure will now decreases. Pressure is decreases. So at this pressure, its temperature is 30 degrees centigrade as in your previous case, 30 degrees centigrade as your previous case. But basic concept, if the pressure is reduced, then saturation temperature of the water will be reduced. Now the temperature is, originally it was 30 degrees centigrade, now it becomes 10 degrees centigrade. So there is a reduction of 20 degrees centigrade. Okay. If it is at 20 degrees centigrade, then what happened? We can use this as a refrigerating effect. So this is the refrigerating effect. That means that this is atmospheric air is 30 degrees centigrade, you see. This is the 30 degrees centigrade. So now heat is, so here this is the object from where heat is extracted. So we can get this refrigerating effect here. Again, the water absorbs heat and the temperature then increases. Temperature increases means now water starts, if it is more than 10 degrees centigrade, now vapor produced at this pressure, vapor will be produced. The next point. Now next point is that, you see, here it abstract heat So there's a refrigerating effect. As a result, what happened? The temperature of water now increases. Now it is 10 degrees centigrade. So the temperature now becomes, it is gradually increased than 10 degrees centigrade. Now, the boiling point of water at 1.22 kilopascal is 10 degree. So if the temperature increases more than 10 degree, then what happens? Water starts boiling. Vapor is produced. Okay. This water vapor now go in this direction because valve is open in this direction here. Okay. Now it will enter here. Now in this case, you see, originally this is 50% lithium bromide. Now 50% water. Okay. Now water vapor added here. So percentage of water in this solution now increases. Water vapor added here. So percentage of water here increases. That means now in the second phase, what happened? Suppose this is 40% lithium bromide and 60% water. We'll call it weak solution. Okay. If the percentage of water increases, we will call it weak solution. Okay. Now, what happened? You see, now you see, if the percentage of lithium bromide decreases, here the behavior of the solution again changes. What is the sense? The sense it said. Now what happened? As it is a now we are adding the water vapor here in the previous case, so it becomes a weak lithium bromide solution. Weak lithium bromide solution means what? What is the meaning? Weak lithium bromide solution meaning that the temperature of this solution now decreases. The original concept is that if we add water to lithium bromide, what happens? The boiling point increases than the pure water. Water has a certain boiling point. Now, if we add lithium bromide, then boiling point increases. That means if the percentage of lithium bromide decreases, then boiling point of this solution decreases. And if there is no lithium bromide, then the boiling point will be the normal boiling point of water. So in this case, what happened? The temperature of the solution now increases. This temperature of the solution increases as the water vapor, more water vapor is added. So this is the basic concept. Now you see, so this is the basic concept. These are the three conditions. One is initial, then refrigeration, and the last one is the regeneration. Now, how the refrigerating effect produce? Doubt is any. So this is the actually basic principle. Now, with this principle, we will use this basic principle in vapor absorption system later on. Here, heat is added. So what we in vapor absorption system, we already we explained that this is a heat addition process. Heat addition process. So to regenerate the refrigerant again, we have to add heat, not the electricity. As in VCR, that is vapor compression refrigeration system, we use the compressor. Instead of compressor, here we will use the heat. Now you see, now heat is added here. Already told that this is a weak solution, weak lithium bromide solution. Weak lithium bromide solution. In our previous slide, we call that this is a lithium bromide decreases as the vapor enter here. As a result, it becomes weak. The solution becomes weak. Now this is the condition in the second phase. So this is the condition. This is a weak lithium bromide solution. Okay. Now we apply heat from the outside. This is the application. As a result, what happened? As a result, from here, the water again boil, water vapor. It's separate because it is separated, from the lithium bromide, water is separated and it becomes vapor. Now this is open. Now this water vapor now enters in this direction and it will be here now. And if the water is separated from the weak solution, now what happened? Originally 60% water, suppose, and 40% lithium bromide in our previous slide. Now, if we add heat, then water is separated from the solution and it goes there. As a result, what happened? The percentage of water in this solution now decreases, goes down. That means the solution now becomes again strong solution. That means in this case, again, the percentage of lithium bromide will be 50% and 50% water. Okay. Now again, the system will come to this level where it is 50% lithium bromide and water. The same phenomena occurs. So this is called regeneration. Regeneration, if we apply heat, water vapor separated from the solution, it boils because lithium bromide will not boil water vapor. Then it becomes the strong solution again. If it is a strong solution, then the same concept occurs here as what we explained in this system. This is the vapor absorption refrigeration system. This is the actual now block diagram. So what is the difference between VCR? VCR what key differences you see? This part is replaced. In VCR, instead of this one, we are using a compressor in case of VCR. VCR khetrot it was. So this is a compressor. But now we replace the compressor by this one. Number one, absorber, expansion device, generator, and pump. So these are used. Okay. So there is a condenser, expansion valve, evaporator. So no power is required to run the compressor. Only we add heat. You see, some heat is added in the generator. Generator means generation of solution. Remember, generator is not the simple meaning. What we mean the generator is a power production generator. No, this is not like this. Absorber means absorbing the refrigerant, and generator means generating the refrigerant. It's the generator. Here, this is the refrigerant. Now, how it will work, you see. The first point is here, low temperature. Try to understand this cycle, you see. Low temperature and low pressure. Refrigerant is at this point. After expansion device, this is the same. This and this one, and this one is same as VCR. VCR, the function is still the same function. Refrigerating effect takes place in the evaporator. So before entering evaporator, in the expansion valve, the refrigerant expands. So it becomes low temperature, low pressure refrigerant. Now this low temperature, low pressure refrigerant enters to the evaporator here. Okay. Now here it absorbs heat from the commodity. So it produces a refrigerating effect here. Now, the next point is the low temperature, low pressure refrigerant with low quality enters the evaporator, already explained, and vaporized by producing useful refrigerating effect. Now, at this point, this is it enters the evaporator. Here, it takes heat and it becomes vapor. This is vapor, refrigerant vapor. After that, from the evaporator, the low temperature, low pressure refrigerant vapor enters the absorber, where it comes in contact with the solution that is weakened refrigerant. What is the meaning? Already we have explained. Weakened refrigerant means, suppose it is the lithium bromide plus water. Okay. So, in this case, the water is refrigerant. Water is refrigerant if this is a lithium bromide solution. So this water now produces vapor here. Now this vapor now enters to the absorber. So here in this absorber, this is a solution of lithium bromide plus water. So already this is weak in solution. Weak in solution means percentage of lithium bromide is, this is very percentage of, weak in solution means percentage of water, because water is the refrigerant, percentage of water is less. Remember, weak in solution, what is the meaning? Percentage of refrigerant is less. In this case, water is used as a refrigerant. Lithium bromide is not as a refrigerant, remember. Water is refrigerant. So weak solution means percentage of water is small or less. So this is the water vapor. This water vapor, this is the heat is absorbed, so it produces the water vapor. This water vapor now enters absorber. In this absorber, this is the solution of lithium bromide and water, where percentage of water is very small, percentage of lithium bromide is more. So water enters here. So it increases the percentage of water. So it becomes strong solution now. Strong solution is refrigerant. Okay. Now, the solution that is now rich in refrigerant is pumped to the high pressure. Now it becomes strong. Now it is pumped with the help of pump. It pumped to the generator pressure. This is the same pressure. Condenser and generator is the same pressure. So it is pumped to the condenser pressure. So it becomes, now it is here in the generator. In the generator, you see, this is a strong solution. Strong solution. Strong solution means percentage of water is more because water is refrigerant. So now here it is a strong solution. In the generator, we apply heat externally. As a result, what happens? From this strong solution, water boils, water vapor, water boils, water vapor. Now, this is the water vapor, water vapor. Now, this water vapor enters here. Here, it gives the heat to the surrounding where temperature is lower. So now water condenses. It is a condense. It is a mixture of vapor plus liquid. So now this one is expanded here. As a result, it becomes, the temperature becomes very low. Pressure reduces in the expansion, so temperature reduces. So this is the cycle. Now in this cycle, what happens? Now as the water boils, so the strong solution now becomes weak because in the solution less water. Now this weak solution now passing through in this way, and it enters to the through the expansion valve. It expanded. As a result, temperature reduces and pressure reduces. This is a high pressure. This is a low pressure. If it passes to the expansion valve, what happens? This high pressure weak solution now expanded. It becomes a low pressure up to the evaporator. This is the same evaporator pressure. Now it enters to the absorber. In the absorber, it is a weak solution now. So this is the cycle.